everyone, this is me again, Resume GS Kote. On behalf of my other group members, I will be reporting about sedimentary rocks. As what I've said earlier, sedimentary rocks are formed on or within the Earth's surface, in contrast to metamorphic and igneous rocks, which are formed deep within the Earth. The most important geological processes that led to the creation of sedimentary rocks are erosion, dissolution, lithification, precipitation, and weathering process either by compaction and cementation of rock mineral fragments. As we all know in the previous topics, erosion and weathering include the effects of wind and rain, which slowly break down large rocks into smaller ones. Erosion and weathering transform boulders and even mountains into sediments, such as sand or mud. Dissolution is a form of weathering, specifically chemical weathering. With this process, water that is slightly acidic slowly wears away stone. These three processes create the raw material for new sedimentary rocks. Sedimentary rocks can be organized into two categories. The first is detrital rock, which comes from the erosion and accumulation of rock fragments, sediment, or other materials, categorized in total as detritus or debris. The other is chemical rock, produced from the dissolution and precipitation of minerals. Now, let's talk about some examples of sedimentary rocks. Some of the common sedimentary rocks include sandstone, limestone, shale, conglomerate, and breccia. These rocks are often started as sediments carried in rivers and deposited in lakes and oceans. When buried, the sediments lose water and become cemented to form rock. Sandstone is one of the most common types of sedimentary rocks, and it is found in sedimentary basins throughout the world. It contains cementing material that binds sand grains together and may contain matrix of slate or clay-sized particles that occupy the spaces between the sand grains. Limestone, on the other hand, is a common type of carbonate sedimentary rock. It is composed mostly of the mineral calcite and aragonite, which are different crystal forms of calcium carbonate. Limestone has two origins: biogenic precipitation from seawater, the primary agents being lime-secreting organisms, and mechanical transport and deposition of pre-existing limestone, forming clastic deposits. Shale is a fine-grained sedimentary rock that forms from the compaction of silt and clay-sized mineral particles that we commonly call mud. This composition places shale in a category of sedimentary rocks known as mudstones. Shale is distinguished from other mudstones because it is fissile and laminated. When we say laminated, it means that the rock is made up of many thin layers, and when we say fissile, it means that the rock is readily split into pieces along the laminations. Black organic shales are the rock source for many of the world's most important oil and natural gas deposits. Conglomerate is a clastic sedimentary rock made up of rounded clasts that are greater than 2 millimeters in diameter. The spaces between the clasts are generally filled with sand and clay-sized particles. The rock is bonded together by a cement that is usually composed of calcite or quartz. Lastly is breccia. Breccia is similar with conglomerate. They are both classic sedimentary rocks composed of particles larger than 2 millimeters in diameter. But what's the difference between conglomerate and breccia? The difference is in the shape of the large particles. In breccia, the large particles are angular in shape, but in conglomerate, the particles are rounded. One of the most common locations for breccia formation is at the base of an outcrop where mechanical weathering debris accumulates. Another is in a stream, which deposits a short distance from the outcrop or an alluvial fan. That's all, and thank you.
I am Giancarlo, the last reporter who will discuss the occurrence, properties, and distribution of metamorphic rocks. Here are the types of metamorphic rocks: quartzite, marble, slate, schist, and gneiss. Quartzite. Quartzite is an unfoliated metamorphic rock composed almost entirely of quartz. It usually forms from the metamorphism of sandstone. During mountain building events at convergent plate boundaries, where sandstones was deposited on a continental plate, there the sandstone is metamorphosed in the quartzite by the intense pressure of a plate collision and often by deep burial. When quartz-rich sandstone or chert has been exposed to high temperatures and pressures, such conditions fuse the quartz grains together, forming a dense, hard, and equigranular rock. When sandstone is cemented to quartzite, the character quartz grains recrystallize along with the former cementing cloth to form an interlocking mosaic of quartz crystals. Most or all of the unique texture and sedimentary structures of a sandstone are erased through metamorphism. The grains on paper-like surface turns into glassine look, Minor amounts of form of cementing substance like iron, oxide, silica, carbonated and clay often migrate during crystallization and metamorphosis. This causes streaks and lenses to shape in the quartzite. Here are the properties of quartzite: texture, granular, grain size, medium grained, and can see interlocking quartz crystal with the naked eye. Color, variable. Pure quartzite is white, but quartzite exists in a wide variety of colors. Mineralogy, quartz. Hardness. Quartzite contains more quartz, about 90 to 99%, giving its hardness of 7, the most hardness scale. Meaning, quartzite is extremely harder and it is often used as a railway ballast. Acid resistance. Completely resistant to acidic. It will not etch from lemon juice, vinegar, or any other acidic food. Porosity. Has varying levels of porosity, with a few varieties being less porous, while some being relatively more porous. This is because certain areas of the sandstone, the more porous parent stone, may or may not have metamorphosed to the same extent as the rest of the stone, meaning chances are that some quartzite may retain the porous nature. For example, highly metamorphosed Taj Mahal quartzite and more porous Kalakata Macabas quartzite. Heat resistance. High temperature help quartzite form and it is relatively heat resistant. When exposed to heat, quartzite doesn't crack or sustain other damage. Durability. Can withstand wear and tear very well. Uses. Pure quartzite is a source of silica for metallurgical purposes and for the manufacture of brick. As aggregate in the construction and roading industries, as armor rock for seawalls, dimension stones for building facings, paving, and many more. The quartzite is abundant in mountain ridges of subduction zones. It can be found in countries like US, UK, continental Europe, and Canada. Marble is a non-foliated metamorphic rock made up almost entirely of either calcite or dolomite, for which the portolith was either limestone or dolostone, respectively. Marble was formed when limestone buried deep in the outer layers of earth crust is subjected to heat and pressure from thick layers of overlying sediments. Marble forms under such condition because the calcite forming the limestone recrystallize, forming a denser rock consisting of roughly equigranular calcite crystals. The variety of colors exhibited by a marble are a consequence of minor amounts of impurities being incorporated with the calcite during metamorphism. While marble can appear superficially similar to the quartzite, a piece of marble will be able to scratch by a metal blade, and marble will feast on a contact with dilute hydraulic acid. Here are the properties of marble. Color, white and pink, derived from limestone and dolomite. Grain size, medium grained and can see interlocking calcite crystals with the naked eye. Structure, massive. Group, metamorphic rocks. Texture, granoblastic and granular. Formation, regional or contact metamorphic. Acid reaction, being composed of calcium carbonate, marble will react in contact with many acids. Neutralizing the acid, it is one of the most effective acid neutralization materials. It is often crushed and used for acid neutralization in streams, lakes, and soils. Hardness, being composed of calcite, marble has a hardness of 3 on the most hardness scale. As a result, it is easy to carve and makes it useful for producing sculptures and ornamental objects. The translucence of marble makes it especially attractive for many types of sculpture. Ability to accept a polish. After being sanded with progressively finer abrasives, it can be polished to a high luster. This allows attractive pieces of marble to be cut, polished, and used as a floor tiles, architectural panels facing stone, window sills, stair treads, columns, and many other pieces of decorative stone. Major minerals of marble is calcite. Accessory minerals of marble are diopside, tremolite, actinolite, and dolomite. Here are some of the uses of marble. Building stone, dimension stone for building facings, paving, and many more. Cut into blocks and cut for monuments, headstone, and many more. Wears over time due to softness of calcite, prone to acid rain damage because calcite is soluble in acid. Whitening material in toothpaste, paint, and paper. Europe and Asia are one of the leading producers of marble around the world. The United States of America is also a high-level marble producer. Italy, China, India, and Spain who dominated global marble production. Slate. Slate is a fine-grained, foliated metamorphic rock that is created by the alteration of shale or mudstone by low-grade regional metamorphism. Slate was formed from the compressive pressure from both sea and the Earth's core. The tectonic environment for producing slate is usually a former sedimentary basin that becomes involved in a convergent plate boundary. Shales and mudstone in that basin are compressed by horizontal forces with minor heating. These forces and heat modify the clay minerals in the shale and mudstone. Foliation develops at right angles to the compressive forces of convergent plate boundary to yield a vertical foliation that usually crosses the bedding plates that existed in the shale. Here are the properties of slate. Texture is foliated. Foliation on a millimeter scale. Grain size, very fine grained. Crystals are not visible to the naked eye. Hardness, hard and brittle. Color, variable, black shades of green, blue, red, brown, and buff. Major minerals are quartz and muscovite, or elite, frequently along with biotite, chlorite, hematite, and pyrite. Accessory minerals, apatite, graphite, kaolinite, magnetite, tourmaline, or zircon as well as feldspar. Here are the uses of slate. Historically extensively used for roof and floor tiles, and also for blackboards. Standard material for the beds of pool, snooker, or billiard tables. In Europe, most slate is mined in Spain. It is also mined in the United Kingdom and parts of France, Italy, and Portugal. Brazil is the second biggest producer of slate. In the America, it is also found in the Newfoundland, Pennsylvania, New York, Vermont, Maine, and Virginia. China and Australia and the Arctic also have large reserves of slate. Schist, a metamorphic rock with well-developed foliation. It often contains significant amounts of mica, which allow the rock to split into thin pieces. It is a rock of intermediate metamorphic grade between pyrite and gneiss. It forms on the continental side of convergent plate boundary where sedimentary rocks such as shales, mudstone, have been subjected to compressive process, heat, and chemical activity. The resulting foliation is coarser and more distinct than that of slate due to higher degree of crystallization of mica minerals, the biotite, chlorite, and muscovite, forming larger crystals, and is often referred to schistosity. These larger crystals reflect light so that schist often have a high luster. Pyoblasts are common in schist, and they provide information on the temperature and pressure condition under which rock form. Due to more extreme formation conditions, schist often shows complex folding patterns. There are many varieties of schist and they are named for the dominant mineral comprising the rock. Mica, schist, green schist. Green schist is a green because of high chloride content, and garnet schist, and many more. Here are the properties of schist. Texture, foliated. Foliation on a scale of centimeter or more. Grain size, medium to coarse grained. Can see crystal with the naked eye. Hardness, hard. Color, variable. Generally alternating lighter and darker subparallel discontinuous bands. Mineralogy. Felsic minerals such as feldspar or autoclays and plagioclase, and quartz generally form the light color bands. Fulvic minerals such as biotite, pyroxene or agite, and amphibole or hornblende or generally form the dark colored bands. Garnet pyroblast common. Other features generally rough to rough. Here the uses of schist. Dimension stone for building facing, paving, and many more. Schists are mostly the Precambrian ages rock. It usually occurs the regional metamorphism of existing rocks. These are usually sedimentary or sometimes igneous rocks. It could therefore be found where eroded mountains reveal the rock, or in areas of glacial deposition of eroded schist. Gneiss. Gneiss is a foliated metamorphic rock identified by its bands and lenses of varying mineral composition. It is formed by regional metamorphism at convergent plate boundaries. It is a high-grade metamorphic rock in which mineral grains recrystallize under intense heat and pressure. These alterations increase the size of mineral grains and segregate them into bands, a transformation which made the rock and its mineral more stable in their metamorphic environment. Gneiss display distinct foliation representing alternating layers composed of different minerals. However, unlike slate and schist, gneiss does not have preferential break along planes of foliation because less than 50% of the minerals formed during the metamorphism are aligned in thin layers. Because of the coarseness of the foliation, the layers are often subparallel. They do not have a constant thickness and discontinuous. Gneiss is typically associated with major mountain building episodes. During these episodes, sedimentary or felsic igneous rock are subjected to great pressures and temperature generated by great deep depth of boreal, proximity to igneous intrusions, and tectonic forces generated during such episodes. Gneiss from western Greenland comprise the oldest crustal locks down. Here are the properties of gneiss. Texture. Foliated. Foliation a millimeter to centimeter scale. Grain size. Fine medium grained and can often see crystal with the naked eye. Hardness. Generally hard. Color. Variable. Often alternating lighter, darker bands, or often shiny. Mineralogy. Mica minerals such as biotite, chlorite, and muscovite. Quartz and plagioclase often present as monomineralic bands. Garnet or pyroblasts common. Structure. Gneiss tend to be banded on the larger scale with layers and streaks of darker and lighter colored gneiss. Granite and coarse veins and pegmatites are common, maybe folded. Parent rock, shale, granitic, and volcanic rocks. The uses of gneiss, dimension stone for building facings, pavings, and many more. Gneiss, being a highly deformed crystalline metamorphic rock, is commonly found in the cores of mountain ranges and in Precambrian crystalline terrains. The rock itself is formed at crustal depths of 10 to 20 km at pressures of 10 kb or more, and temperatures between about 500 to 700 degree Kelvin. So, at depths where rock becomes quasi-viscous, high-grade minerals such as biotite and garnet form that lend a characteristic foliation or banding. But just below temperatures where quartz and feldspar and muscovite begin to melt and or break down and form veins of granite. There are varieties of depending on mineral composition and texture, but all gneiss is evidence of deep crustal deformation. Gneiss from western Greenland comprise the oldest crustal rocks known, more than 3.5 billion years old. The study of gneiss is an important part of metamorphic petrology. Did you know that with increasing temperature and pressure, metamorphic grade also increases? The higher the metamorphic grade, the more changed the rock will be from its original form. Example, increasing metamorphic grade shows slate to pyrite to schist to gneiss. That would be all for our report. Thank you.